Okay. Hi, everybody. My name is Virginia Trueheart. I am the manager of the frontline support team for the Texas Advanced Computing Center. We're here to help you with any problems with your jobs or any questions you have about running at TAC and the best way to do your research. And today I'm doing a very basic introduction to the language of HPC. These are terms that you'll encounter anytime you open tickets or interact with the portal. And this just is designed to give you some context about what these terms mean and how we use them in the context of HPC. So some of these terms you'll recognize from normal everyday language, but in terms of high performance computing, we use very specific definitions of these terms in order to convey certain things within the research field. So when you get started, your PI will need to add you to a project with an active allocation in order to log into a TAC machine. So if you've started working at TAC and you created an account in the portal, but you are unable to log into a machine, that's because you're not likely on an active allocation. To define these things, your PI is the principal investigator. This is usually your professor or postdoctoral student who's in charge of your lab, or some other sort of research team lead if you don't necessarily work in a purely academic sphere. These are the people that have designed and established the research project that you'll be working on, which specifically is the project name which you will be working under at TAC. For each project, you will be granted an allocation, which is time granted on a specific TAC machine that's associated with the project. So each project can have multiple allocations. Allocations are tied to specific machines, such as Stampede or Frontera. And depending on the needs of the researcher and the research project, you might need access to multiple machines. So say my project name is Black Hole Study. And for Black Hole Study, I need to do some high-level computations using CPUs, but I also need to do some image rendering to sort of display patterns found in the research and for publication. In that case, you need access to CPUs and GPUs. But if your original allocation is on a machine such as Stampede 2, there aren't any GPUs available, in which case you would get an additional allocation on a machine like Frontera or Lone Star 6 that has GPUs available. So in this case, the project name would remain Black Hole Study, but you would have two allocations associated with that project, one for Stampede 2 and one for Frontera. Your access to these allocations is measured in what we call SUs. SUs stands for service unit, and this is how we calculate the cost of running at TAC. While running at TAC doesn't cost you any actual money, we still have to have a way to measure the interaction you have with the machine. Because the machines are shared between several thousand users, it's important that we distribute the access in as even a way as possible. So depending on the research needs of your particular project, you'll be granted a certain number of SUs based on your allocation application. Now, each job you run on a machine will consume SUs, and therefore the larger pool of SUs you will granted for the allocation will reduce every time you run a job. And we calculate the number of SUs billed by multiplying the number of nodes your job has used, the number of wall clock hours your job has used, and a charge rate per node hour. The number of nodes and the number of hours is pretty self-explanatory, but the charge rate can vary per machine and also per queue. So on Stampede 2, there is a normal queue, an SKX normal queue for SKX nodes, and an ICX normal queue for ICX nodes. Each of these jobs runs at a different charge rate. If you run in the normal queue, the charge rate is 1. So one node times 1 hour times one charge rate means you would build one SU to run a one node job for an hour. However, if you want to run on the slightly, we'll say more popular queues, such as SKX or ICX, the charge rate will increase. So ICX nodes at the highest rate are 1.6 charge rate per hour. So the increase can be significant, but usually we try to keep it in a reasonable range. Also, I think I misspoke earlier. The normal queue charge rate is 0.8. The SKX normal is 1. So it's a little bit cheaper to run in the normal queue. Regardless, each billing for each job will then be assessed from the pool that you were granted for your allocation. This allocation will be used by everyone on your project, so make sure you share with all of your coworkers. Now, when you run jobs at TAC, you can either run interactively or you can submit match jobs using the slurm commands. Jobs can also be run serially or in parallel. An interactive job means that you're running a job on a node directly and that you're actively interacting with it. This is similar to something like Jupyter Notebooks, where if you run a command, you can immediately see the result in the terminal. You are on a compute node, you are interacting with your job, and every change that you make is something that you can see in real time. However, waiting for nodes to become available in the queue can take quite a while. So if you know that your job runs well and you want to walk away from your computer for a while and don't need to make any adjustments interactively, you can submit jobs in a batch style. In this case, we use a system called Slurm, a simple Linux utility for resource management, to control the workloads on the machine and also to submit batch jobs. In fact, we use a command called sbatch or Slurm batch in order to submit batch jobs to the queue. ideb is how you launch an interactive job. Each of these options is perfectly valid for running a job, though they are specialized depending on what you want to work on. ideb we consider to be interactive development. So when you run interactively, typically you're troubleshooting your job or looking to make modifications on the fly to perfect your job. Afterwards, you will then want to submit your job in batch so that you can either run multiple jobs at a time or simply submit the job to the queue and then wait for it to complete on its own. You don't have to actively watch the queue or wait for a node to become available. This makes it a lot easier if you have particularly large simulations that need a lot of nodes, because those jobs tend to sit in the queue longer. So it makes it a lot easier if you can submit a job, say, at 2 p.m. and then not worry about it until the next day. You don't have to actively sit on the computer waiting for the node to become available. You can also run jobs serially or in parallel. This gets into the coding end of how jobs are run at TAC. Serial jobs are run as one task on a single core of a node. Nodes like the SKX nodes have 48 cores per node. So for a serial job, you could run one task on one of those 48 cores and then run another task on that same core after the first task is done. So they follow in a serial line until each task is completed and the job is done. Alternatively, depending on your code, you can also run in parallel. This allows you to run jobs doing all tasks simultaneously across multiple cores. So if you've parallelized your job sufficiently, you could run 48 tasks, one on each of the 48 cores on an SKX node. This allows you to complete the job more quickly, but also allows you to develop a sense of scaling. Not all jobs can accommodate parallel computation, but it's good to know that the option is available. Parallel jobs also tend to provide a larger amount of output and also tend to complete a little bit faster. So these are some very basic terms about working in high performance computing. Obviously, there are many more that we could talk about, but this is just a short little introduction to things you might encounter when you very first start running on a high performance computing system. And we're happy to answer any more questions you might have via the TAC support portal. We also have many training materials available, as well as complete user guides for each machine at TAC available at the TAC user portal, which you can access at portal.tac.utexas.edu. Thanks for taking some time to hang out with me this morning, and I hope you have a lovely day.